This question tests your knowledge of different kernel approximation methods in scikit-learn. I'll help you understand each method. Remember, we're looking at ways to speed up support vector machines, SVMs, with nonlinear kernels for large datasets. Kernel approximation is a clever technique for doing just that. This is the overall topic. We are exploring kernel approximation methods within the scikit-learn library in Python. Scikit-learn is a fantastic tool for machine learning. Nystrom is a smart method. Instead of working with the entire dataset, which can be huge and slow, I only use a smaller part of it to create a good approximation. Think of it like using a small, representative sample to understand the whole picture. It's a great way to save time and resources. The radial basis function, RBF, kernel is a popular choice for nonlinear SVMs, but calculating it directly can be very expensive. RBF sampler uses a cool trick called random Fourier features to approximate the RBF kernel much faster. It's like using a shortcut to get a pretty good result. The main reason we use kernel approximation is speed. Computing the kernel matrix for huge datasets is incredibly slow. Kernel approximation methods offer a significant speed boost by trading some accuracy for computational efficiency. It's a trade-off worth considering for large-scale problems. Categorical data is data that consists of categories or labels rather than numbers. Additive Chi2 sampler is specifically designed to work well with this type of data. It helps us deal with kernels efficiently when we have many categories. This question asks you to identify the correct statements about how scikit-learn handles kernel approximation, specifically focusing on Nystrom RBF sampler and additive Chi2 sampler . It's all about efficiency. When dealing with massive datasets, directly calculating the kernel matrix becomes computationally expensive. These methods offer faster alternatives. I'll explain NYSTROEM. Imagine you have a huge pile of data. Nystrom cleverly picks a smaller, representative sample from this pile. It uses this smaller sample to create a close approximation of what the full kernel matrix would look like, saving a ton of computation. Now for RBF-SAMPLER. The radial basis function, RBF, kernel is popular but computationally heavy. RBF sampler uses a clever trick. It leverages random Fourier features to get an approximate representation of the RBF kernel, leading to quicker computations. This statement highlights the core advantage of kernel approximation techniques. Calculating the entire kernel matrix for large datasets is slow. Kernel approximation methods provide a speed boost by trading some accuracy for much faster performance. Finally, let's talk about ADDITIVECHI2SAMPLER. Categorical data, like colors or types, isn't easily handled by standard kernels. Additive Chi2 sampler is specifically designed to work well with this type of data by approximating kernels relevant to categorical features. This is a multiple-choice question testing your knowledge of scikit-learn's kernel approximation methods. I'll help you understand the different options. This question asks you to identify which statements accurately describe the functionality of scikit-learn's kernel approximation module. We'll look at each statement individually. Statement A is correct. Nystrom is a smart method. It uses only a part of the data to estimate the entire kernel matrix, making computations faster. Statement B is also true. RBF sampler specializes in approximating the popular radial basis function, RBF, kernel using a technique called random Fourier features which are super efficient. This is correct. The whole point of kernel approximation is to save time and resources when dealing with massive datasets. They're much faster than directly calculating the kernel matrix. Statement D is true. Additive Chi2 sampler is designed specifically for categorical data. Data that's in categories like colors or types, not numbers. This is the overall topic. We will learn about different methods for approximating kernels within the scikit-learn library. Making large-scale machine learning tasks more manageable. That's the final answer. All the statements provided are correct descriptions of the capabilities of the various kernel approximation methods found in scikit-learn. I hope that was helpful. I'm going to explain scikit-learn's tools for quickly estimating kernel functions. These are super helpful when you're working with massive datasets. Imagine having a gigantic spreadsheet. Calculating the kernel matrix directly would take forever. These methods provide a shortcut, a clever approximation that's much faster. We'll explore a few key methods shortly. Get ready. We're dealing with a huge dataset and want to use a support vector machine, SVM, with a fancy, nonlinear kernel. The issue is, calculating the kernel matrix for such a large dataset is incredibly slow and computationally expensive. That's where kernel approximation steps in to save the day. I'm solving this problem with kernel approximation. Instead of directly calculating the kernel matrix, which is the heart of the SVM's computations, I'm using clever methods to approximate it. This yields significant time savings while maintaining acceptable accuracy. The Nystrom method is like taking a smaller, representative sample of your giant dataset. I use that sample to construct a smaller, approximate kernel matrix that stands in for the whole thing. It's super efficient for handling huge datasets. RBF sampler is specialized for approximating the radial basis function, RBF, kernel. RBF kernels are very common in SVMs for modeling nonlinear relationships in data. It cleverly uses random Fourier features to speed things up considerably. Using these kernel approximation methods is much faster than directly computing the full kernel matrix. This difference is especially dramatic with large datasets. The trade-off is a little less accuracy, but the time saved is often worth it. This method is perfect for categorical data. If your data is made up of categories, like colors or types, rather than continuous numbers, this method excels at approximating the kernel. Think of it as being specifically designed for data presented as histograms or frequency counts. This is a multiple-choice question. The answers given earlier are actually related to this question. We already discussed the correct options, which are A, B, C, and D. I'm focusing on scikit-learn's tools for quickly estimating kernel functions. These are crucial when dealing with massive datasets where computing the full kernel matrix is too slow. Let's test your knowledge of these kernel approximation methods. I'll present a multiple-choice question, and you'll select the correct answers. This question directly probes your understanding of scikit-learn's _kernel_approximation module. It focuses on whether you know how different approximation methods work. The NYSTROEM method cleverly uses a small piece of the data to represent the whole kernel matrix. It's like creating a mini representation that stands in for the much larger, more computationally expensive, full picture. The RBF-SAMPLER specifically handles the common radial basis function, RBF, kernel. It leverages random Fourier features to make the approximation faster. Think of it as a specialized tool for a frequently used kernel. The whole point of kernel approximation is speed. For massive datasets, computing the full kernel matrix is slow. Approximation methods offer a significant shortcut, trading a little accuracy for a huge boost in performance. The ADDITIVECHI2SAMPLER is designed for categorical data. Data that is divided into distinct categories or groups, not continuous values. It's the right tool if you're dealing with that type of data. The answer is all of the above. Each statement accurately describes a key aspect of scikit-learn's kernel approximation methods. This question tests your understanding of how scikit-learn handles kernel approximation, a technique used to speed up support vector machines, SVMs, with large datasets. I'm asking you to identify which statements correctly describe the behavior of different kernel approximation methods within scikit-learn. It's all about efficiency versus accuracy. I agree completely. That's the whole point. When you have massive amounts of data, calculating the full kernel matrix, that's a matrix representing all pairwise similarities between data points, becomes incredibly slow. Kernel approximation methods offer a clever shortcut. They estimate the kernel matrix, making the process much faster. Think of it like using a summary instead of reading every single page of a book. It's a trade-off. You lose some accuracy, but you gain a huge amount of speed. Yes. Additive Chi2 sampler is specifically designed to handle categorical data, which represents data as categories or groups rather than numbers. Imagine you're analyzing customer preferences for different colors. Additive Chi2 sampler is a great choice. Absolutely. Nystrom works by selecting a smaller, representative sample of the data. Then, it uses this subset to construct an approximation of the complete kernel matrix. It's like building a smaller, representative model of the entire dataset to make calculations faster. Precisely. RBF sampler focuses specifically on approximating the radial basis function, RBF, kernel, a popular choice in SVMs. It uses a clever technique called random Fourier features. This method transforms your data into a higher dimensional space where the RBF kernel computations become significantly easier. It's like making a complicated calculation simpler by changing your perspective. I'm talking about a collection of techniques in the scikit-learn library that help you speed up support vector machines, SVMs, by cleverly approximating the kernel matrix. This is super helpful when you're dealing with massive datasets where computing the entire kernel matrix would be painfully slow. Think of it as a shortcut that gets you pretty close to the exact result without all the extra work. This is a multiple-choice question that tests your understanding of the different kernel approximation methods in scikit-learn. You'll need to know which method does what and when to use each one. This question is going to check your knowledge about scikit-learn's kernel_approximation module. You'll be looking at some statements and deciding whether each one is right or wrong based on your knowledge of how the module works and what its different functions are used for. Statement A talks about the Nystrom method. I use a smaller part of my data to create a faster estimate of the complete kernel matrix. It's a great way to save time when dealing with a large dataset. Statement B is about RBF sampler . This method specifically focuses on approximating a commonly used kernel, the radial basis function, RBF, kernel, using a clever mathematical trick called random Fourier features. This leads to faster calculations. Statement C is a general statement about kernel approximation methods. The key idea here is speed. These methods are much faster than computing the full kernel matrix, especially with massive datasets where computing the full kernel matrix would be incredibly time-consuming. Statement D discusses additive Chi2 sampler . This method is specifically designed for categorical data. That means data that is in categories or groups, like colors, red, blue, green, rather than numbers. This is a specific kernel approximation method within scikit-learn that is named after the mathematician. It's a key player in reducing the computation time required to handle large datasets. This is a specific method for approximating the radial basis function, RBF, kernel. RBF kernels are popular choices for support vector machines, but can be slow to compute, so RBF sampler is here to the rescue. This method is designed for categorical data, a type of data that involves categories or groups rather than numerical values. This is a general term for any method that finds a faster, but close enough, approximation of the kernel matrix, a key component in support vector machines. The goal is to get a speed boost without sacrificing too much accuracy.